Okay, friends, let's talk about net ionic equations. So at this point, you should have already looked for the net ionic note sheet. It should say writing net ionic equations right up at the top. The second page of that document is going to look like this, and it's going to be some practice problems. So if you've not yet had a chance to go over the note sheet first, please pause this video and go do that now, and then we'll review using this PowerPoint. Okay, so why do we care about net ionic equations? Basically, these are all double replacement equations, and we only care about the final product that's actually the solid. So if you remember, double replacement reactions can only occur if you have a solid and a liquid, or the aqueous part of your products. So in these, we're going to look a little bit closer at what the solid is, and we don't really care about that final aqueous product anymore. So using this process, we've actually done a lot of it. We've done the balancing, you've done the predicting of the products, and you've decided which one is solid and which one is aqueous. So we're just going to take it one more step. So number one, you're going to follow those crisscross rules to write down the reactant. So this is if you're given maybe the name in words rather than the actual formulas. You're going to rearrange those ions to create the products, and that's when you're taking the two outsides, combining them together, and then you're taking the two insides and putting those together, so that way those are your two final products. Looking at your two final products, you're going to use that half sheet green solubility chart to decide which one is insoluble, so that's the capital I on your chart. That is now your solid of your solution. This is the only part that we care about now. So we're going to rewrite the equation using only the precipitate, so we're going to take just that product, and that's now our only product. And then we're going to split that up. Your reactants are now just those two original ions. And then we actually will balance this final equation. So let's see what the heck this looks like. It's actually just a much shorter equation, which is nice. So I'm going to look at number one from your practice problem. So take a second to get that out. What it's asking us to do first is we're going to balance. So this goes way back to the beginning of the unit where you take inventory of either side. So I'm going to add a 2 in front of my NaOH and a 2 in front of my NaNO3. So now all of my reactants and products are balanced. Now I'm going to look at this guy right here. So I notice that this is my solid precipitate. That is now going to become my new product, the only product in my net ionic equation. So if you look here, maybe, perfect. So now if you look here, I basically just dragged down that nickel hydroxide, and that's my only product. And then I have split it up into two original ions that ended up crisscrossing to create the nickel hydroxide. Don't forget to include those original charges. And notice that we've also balanced it because we had two hydroxides here, and we have two hydroxides here now, and still one nickel on either side. Okay, remember that your original ions are going to be aqueous always, just like they were up at the top. Now, get rid of that bad boy. So now I'm going to look at number 9, and that's all the way down at the second half of your practice worksheet. So first it's asking you to predict the products. So again, that's going to be taking the two outsides, combining it with the two insides. So let's look at that. Okay, so notice I took the PB and the SO4, have crisscrossed those. I took the Na and the NO3, and I've crisscrossed those. And then I used my solubility chart, and I decided that PbSO4, if you look at where they meet, it's going to be an I for insoluble, so we're going to label that as our solid. So again, when I'm writing my net ionic equation, that's the only one that I care about now at this point. The other one is going to be aqueous, and he's just a spectator. So now, if I'm going to write out my net ionic equation, I drag down my PbSO4, still a solid, and I'm going to separate it out into the two ions. So I've begun with lead, Pb2+, and SO4 2- sulfate. So notice that those 2s, we need to remember to include them even though they did not really appear in the final products, and that's just because they got simplified out. Okay, so that is that for number 9. So now this should help you to give you a little bit of a guideline, an example of what each of those types of problems look like. I want you to complete the rest of this sheet. There is a Net Ionic quiz on the Google site that I'd like you guys to complete by Friday, 3/20 at 8 a.m. And that will go in as just a small quiz grade, okay? If it's a short answer, it will probably get marked as wrong because Google doesn't understand all the pluses and minuses. I will go back in and personally check to make sure that your answers are right. All right, email me with any questions. Thanks, guys.